The SAA is designed to cater to projects utilizing GitHub as a Git source and Jira as a bug tracking tool. If you want to integrate your GitHub and Jira accounts with SAA, you will need to install SAA from both GitHub and the Atlassian Marketplace for your project instance. This will allow SAA to access your project data. Once you have installed SAA, you can enter the credentials of your Neo4j instance or opt to use a sample SAA Neo4j instance. Setting up a new project with SAA is an easy and streamlined process for users. The first step involves data retrieval. Users can select from GitHub and Jira instances that they have given access to SAA. Also, they opt to add an initial landing comment under the pull request in the GitHub repository and issues in the Jira instance. SAA also allows users to clean and filter data. After confirming the collected information, SAA constructs the project's artifact traceability graph. From the initial landing comments automatically generated during the setup, users can navigate to the SAA to inquire about a specific software artifact on the drawing canvas. For instance, users can navigate to the SAA from the Jira issue panel. The loaded graph includes the respective issue and its first-degree neighbors. Users can easily expand the graph and trace pathways between artifacts by using the context menu specific to each node type. For instance, by using the context menu of an issue node, users can access code files related to that issue. Alternatively, users can initiate graph loading from the Map, Query by Rule tab located in the right sidebar. They can create their own rules using relational and logical operators and load the software artifacts or relations that they want to inspect. While inspecting the artifacts, users may come across situations where they need to inform others, such as identifying bad practices in a project. In those situations, users can report their observations about project software artifact traceability graphs directly to GitHub and Jira platforms in case they are authenticated. For reporting, users select the artifact node on the canvas, go to Object Report tab in the sidebar, specify the pull request, compose a comment, and report it to GitHub. This will associate a new comment with this content in the respective pull request. Finding knowledgeable developers for source code files is critical. This feature facilitates the identification of experts who have contributed to specific files. To begin the process, users should first select a specific file from the drawing canvas. Once they have done that, they can navigate to the Object Queries tab of the selected file and choose the Expert Recommendation option. Users can specify the desired number of recommendations they want and choose whether they want to view the results in a graphical format or not. There are also additional customization options available, such as clustering results or adding badges for further insights. After completing these steps, users will receive recommended developers along with a graphical representation that includes traceability information. The SAA project provides a comprehensive representation of contributions made by developers. This includes non-committed contributions that affect the source code file. When we examine the Git blame of the same source code file, we can see that Michel Mostarda has made more commits than Peter Ansel. However, if we consider other artifacts like pull requests and issues related to the file, Peter Ansel's overall contribution is higher, as the graph shows. The selection of appropriate code reviewers is important for a smooth process, as it can become high maintenance if the assigned developer is not familiar with the code. SAA uses the latest software analytics research results to aid visual analysis. For example, we utilize a method called RSTrace Plus for our reviewer recommendation feature. RSTrace Plus achieved a top 3 accuracy of 0.9 and a mean reciprocal ranking, MRR, of 0.8, proving its reliability. To access the SAA reviewer recommendation feature, users can navigate from the SAA landing comment in the pull request. Then, they will receive a list of recommended developers, along with a graphical representation of traceability information. Alternatively, reviewer recommendations for pull requests can be obtained with the same flow as expert recommendations. If SAA has write access, by selecting the suggested reviewer and clicking Assign, they can swiftly assign reviewers. It is important to communicate these decisions to others, which SAA facilitates by allowing users to report assignments with clear explanations and visual representations of the graph. Finally, they report the assignment to GitHub as a comment, ensuring transparent communication and collaboration. SAA provides detection features for numerous types of bug process anomalies identified and classified by Kumar et al. For accessing issue anomaly detection queries, users can navigate to the Custom Queries section and select the Get Anomalies option. These anomalies encompass anomalies like unassigned bugs, missing links to bug-fixing commits, ignored bugs, and more. Users receive a text result where each issue is represented with related information that demonstrates the anomaly cause. Acknowledging that specific anomalies, such as ignored bugs, may require custom thresholds to qualify as anomalies, SAA provides customizable settings within the Setting Anomalies tab. Users can also check and add anomaly queues on the issue nodes by clicking Highlight, Check Anomalies option from either the menu bar or toolbar. Once activated, anomaly queues, represented as badges, appear on the issue nodes within the drawing canvas. The Anomaly Statistics feature simplifies the process of detecting issues with a higher number of anomalies. Users can access it from the Custom Queries section, where they can select Get Anomaly Statistics and set a threshold count. After setting the count, the user will receive a list of issues that have at least that number of anomalies. In addition, SAA allows users to report their observations about detected anomalies and issues to Jira. Within the reporting interface, users can include attachments such as anomaly details and visual representations to provide additional context. They can also provide further comments on the issue if necessary. Finally, the user can report the identified anomalies to Jira under the respective issue. This process ensures that anomalous issues are promptly identified, documented, and addressed within the collaborative project management environment.